Hello, this is Mr. Melu here, your online math teacher, and welcome to my channel. Today we're going to be continuing my series on analyzing functions from a pre-calculus perspective. And if you find this video helpful, please consider smashing the like button, subscribing, and checking out my other videos. So, in particular, today we're going to be talking about the idea of continuity and discontinuity. So, in order to do this, let's look at an intuitive definition of what it means for a function to be continuous. So, a function is continuous on an interval if you can draw a graph of the function without removing your pencil from the paper. Now, this is intuitive. You need limits, which are the starting point of calculus to write a rigorous definition, so I don't want to use that right now. So, anytime you have a picture and you can draw the graph without picking up your pencil, you're going to have something that is continuous. If you have a picture that you can't do that for, so maybe it's something weird like this. I'm going to put this little hole here. I have to pick up my pencil to be able to go from this left side to the right-hand side of the graph, no matter what. So this is not continuous. So here's our rough idea of what continuous is. You don't have to pick up your pencil to draw it. Now, typically in your classes, you're going to talk about continuity in terms of discontinuities, because that's something that's interesting to study. Where is your function bad in a sense? And the discontinuities are typically going to occur at those spots where you got to pick up your pencil. And there's going to be two types. The kinds that are removable and the kinds that are not removable. So I'll show you what this means. Removable is something like this. I just have, and I could have a little point up here too. I could draw this function except for the fact that I have this little hole here and put the dot up there. And it makes it removable because just by changing one point, I've made my function continuous. So, a function has a removable discontinuity if by changing the value of one point on our function, we can make it continuous. So redefining the function at this one point A, we could make it continuous here. So that's what's going to make it removable. Now, most of the discontinuities you will encounter are of the non-removable kind. So, and those are the following. A jump discontinuity, which just means something that I have to just pick up the pencil to be able to continue drawing like this. So I just have to jump up or down a level to get to the function. Kind of think of it like steps, if you want. The second type is an infinite discontinuity. So what that means is anytime you have an asymptote involved, that means that you have an infinite discontinuity at that asymptote. So that asymptote's at x equal to a. Our jump occurs at x equal to a over here. And then the last type, which you won't see quite as much, is something called, it's due to oscillation. And what these are functions that look like they're approaching two values at once. So a common one that people will see is something that bounces between -1 and 1, and it gets really tight in how much it's bouncing between it as you get towards the y-axis. And this function in particular you could think of as 1 over sine of x if you know what the graph of sine looks like. But these are a lot less common for you to deal with in your pre-calculus class. So infinite discontinuities, you could think of something like this, or oscillations. Infinite discontinuities, any type of function with asymptotes. So things like 1 over x, 1 over x squared. So think asymptote. Jump discontinuities, and you can think of piecewise defined functions. Piecewise. And for removable, you're going to be looking at functions that when you factor them, typically, you could cancel in a sense to get a function that looks nice. So an example of something that would have a removable discontinuity would be the function f of x is equal to x plus 3 times x plus 2 divided by x minus 5 times x plus 2. Normally, you would say there's a bad point, in a sense, or a discontinuity at the value of x is equal to negative 2, because then you'd be dividing by 0 when you plug in the value of negative 2. But because you can cancel, in a sense, and you can't really cancel them, the x plus 2 in the denominator with your x plus 2 in the top, you can effectively remove the discontinuity. So this is just a little extra information, but these pictures really explain what these discontinuities are. Now, let's look at an example of a function that has lots of different types of discontinuities for us. And here's a complex function that I've drawn in Desmos. So it's a piecewise function, so it's really weirdly defined. And you can see 3 types of discontinuities in here. We have an asymptote between the red function and the blue part of our function. So since you'd have an asymptote right here, you would end up having an infinite discontinuity, and that's going to be located at x is equal to negative 1. So there's a removable discontinuity at x is equal to 1, because there's this little hole here that I can just redefine my function at that one spot, and I can make it so I would no longer have to pick up my pencil when tracing the blue and green part. I can just go right from one to the other. And then there's a jump discontinuity over here between our green and our purple functions, because I have to pick up the pencil and jump up or down on the graph to be able to continue drawing the next part of it. So these are the types of things you're going to be looking for when you're graphically trying to identify discontinuities. And wherever those discontinuities are, that's where we're going to say our function is continuous, and you're going to just find where it's continuous based on those x values. So I hope you found this video helpful. If you did, smash the like button, check out my other videos, and have an awesome day.